Greatest common factor and factoring by grouping. In this chapter, we're going to tackle these concepts. So first, let's memorize or let's recall how we find the prime factorization of 84. So we're going to write 84 as the product of two numbers, not necessarily prime. So I wrote 84 as 4 times 21. Then I'm going to write 4 as the product of two prime factors and 21 as the product of two prime factors. Finally, I'm just going to write the numbers with exponents, and this is the prime factorization of 84. If we need to write the prime factorization of negative 210, so first of all, think of negative 210 as the product of two numbers, not necessarily prime. Then keep breaking the composite numbers into prime product of prime factors. So this is the prime factorization of negative 210. Now, if we have letters, we're just going to write the letters without the exponents, and 45, we're going to write it as 9 times 5, and then we're going to break 9 into 3 times 3. So this is the prime factorization of 45a squared b cubed. Keep in mind always to write the variables without the exponents. Now, the greatest common factor of two numbers or more is the largest number that can divide into all of the numbers given. So if I want to find the greatest common factor of 42 and 60, first I'm going to write the prime factorization of 42. Then I'm going to write the prime factorization of 60, take the common factors, and multiply them once. So the greatest common factor is 6. So 6 is the largest number that can go into 42 and 60. Another example, we're going to write the prime factorization of 40a squared b and the prime factorization of 48a b to power 4. Take the common factors and multiply them once. So the greatest common factor is 8ab. Another example. So this is how we write the prime factorization of 70x cubed, 30x to power 4, and 60x to power 7. So always write the common factor under each other so you can see what do we have in common. So the greatest common factor is 10x cubed. Another example. Now here we have the sum of two terms and they have something in common. So the common or the greatest common factor of these two terms is 7. So we're going to factor out 7 and then 7y divide by 7, the answer is y. And that's where the y came from. Then 42 divided by 7, the answer is 6. And that's where the 6 came from. Another example, we have the sum of two terms and the greatest common factor of these two terms is 3y. So we're going to factor out 3y from these two terms. Then 12y squared divided by 3y, the answer is 4y. And that's where the 4y came. Then 3y divided by 3y, that's 1. And that's where the 1 came. Now, another example, we're going to pull out the greatest common factor. So the greatest common factor is 4y to power 4. So we're going to factor 4y to power 4. And we're going to have inside the parentheses 2 minus y squared. To find 2 minus y squared, we use division. So 8y to power 4 divided by 4y to power 4. The answer is 2. Then we have 4. Then we have 4y to power 6 divided by 4y to power 4. The answer is y squared. Now we're going to see factoring by grouping. So we have a polynomial with 4 terms, and we're going to factor by grouping. So we're going to divide this polynomial into 2 groups. Notice from the left-hand side, the greatest common factor is 3x squared, and the right-hand side, the greatest common factor is 2. Now, we have a common term also between the 2 groups we have. Therefore, we can factor 2x minus 3 out. Another example where we need to factor by grouping. So we divided the 4 terms into 2 groups. From the right hand side, the greatest common factor is x squared. From the left hand side is 1. These two terms are the same. Another example. From the left-hand side, the greatest common factor is x squared, and from the right-hand side, the greatest common factor is negative 1. More examples. And this is all for this chapter.